Hi everyone, welcome to today's webinar, Bridging Design and QC Innovations in Surface, Texture, and Appearance Measurement with PANTORA and Rhopoint Aesthetics. Presenting today is Thomas Meeker, a 3D solution architect at X-Rite Pantone, and Christian Dietz, the Director of Technology at Rhopoint Instruments. I just want to go over a couple of things before we get started today. Due to the number of people that are attending today's webinar, we will keep everyone muted. If you have any questions during today's presentation, please feel free to use the questions function on the GoToWebinar panel, and we will have some time at the very end of this webinar to answer a few of your questions. Finally, this webinar will be recorded, and we will follow up at the end with an email to the link to the recording. So with that, I will turn it over to Thomas to get things started.
Excellent. Thank you so much, Robert. Really appreciate the introduction, and thanks, Christian, for joining us today. We're really excited about this new partnership with Rhopoint, bringing in some of their hardware to work with our software, PANTORA. This is a new launch for X-Rite. The Rhopoint device, the Aesthetics device, has been offered by Rhopoint for a little while, but with our new partnership, that brings us into bridging design and QC. So we're going to be talking about innovations in surface texture and appearance measurement, utilizing PANTORA and the Rhopoint Aesthetics. So so just to introduce myself, my name is Thomas Meeker. I'm a 3D solution architect with X-Rite Pantone. I cover North America for our appearance portfolio, so what we also refer to as going beyond color. So measuring materials for more than just color, but also for other appearance attributes, so that we can both communicate and visualize materials. And Christian will get a chance to introduce himself a little bit more, but yes, he is the Director of Technology for Rhopoint Instruments. So this new partnership with Rhopoint, so bringing together X-Rite Pantone as well as Rhopoint. Rhopoint's the market leader in camera-driven surface appearance measurement. You may be familiar with some of their other products as well. We'll be talking about aesthetics today. They're an innovative state-of-the-art QC solutions which help their customers to measure the unmeasurable. X-Rite Pantone being the market leader in color communication measurement. So this is why we're coming together to bring, core competencies from the two organizations to bring together color and other appearance information. So through our technology and market knowledge, we elevate the reach from pure color to total material appearance communication. So what's our mission? So it's specific to the appearance technology. We're trying to enable customers to be able to deliver, design, and promote the adoption of our new file format. Well, I should say it's not new. We've been doing this for over 10 years now, but it's our AXF file, and I'm going to talk a little bit more about that shortly. The idea is that we want to be able to standardize and help capture, store, and edit and communicate complex color and appearance data, but also be able to attach metadata to that. So as people are building their digital libraries of materials and colors and things like that, being able to attach metadata becomes extremely important in database management and digital asset management. So we often refer to these as digital twins. So think of it as the digital twin of its physical counterpart. So to speak more about the AXF file, so the AXF allows the creation of highly accurate digital material databases that enable brands to create photorealistic, achievable designs and prototypes. So being able to utilize this data to be able to use in virtual prototyping and communicating between the different parts of the organization, to help create better customer engagement for brands. So we also enable digital validation. So not only being able to measure these materials, but validate them in a quality control process for faster approval loops. Hopefully the goal is to reduce the amount of physical samples by communicating more digitally, and by using virtual prototyping, reduce shipping costs and things like that as well. So what is material appearance? So if you've been to one of my webinars or one of our webinars talking about appearance, you've probably seen this slide before. We're not just talking about color. We're not just talking about a picture. We're talking about the full appearance or visual sensation through which an object is perceived to have attributes such as color, of course, but also texture, gloss, transparency, translucency. All these different characteristics become very important and are possible through utilizing our hardware and software, and also now with our partnership with Rhopoint. So how was this done in the past? So how were people creating virtual materials? So in the beginning and still today, a lot of this is done through an artistic process. Well, as an artist myself, we do our best to try and match reality, right? Well, there is a subjective nature to that. And what we're really trying to do is give you the confidence that what you see is what you get. So taking that subjectivity out of it, right? So we move from simply artistic processes to using things like texture scanners. Again, those work very well, but they're not true measurements and are limited to, say, the color gamut of the scanner or the camera or whatever is being used. So we want to be able to utilize full physical measurement or digital measurement to be able to do the full appearance of those materials, measuring spectrally, things like that. So this is always a fun slide because I get to ask the question, which one is the physical and which one is the virtual? There are some giveaways here, I will admit, but maybe take a second, take a look, and we'll see if maybe you were correct. So on the left is the virtual material, on the right is the physical material. So on the left, this was a 3D rendering of the material, the AXF file, on the CAD geometry, utilizing a virtual version of our SPLQC light booth. And then on the right-hand side is a photograph, also taken in the physical version of the SPLQC light booth. And so we can do a comparison to make sure that all of those characteristics are in fact being represented in the digital version. But not only do we need there to be parity between the virtual and the physical, we also need that parity to be seen across different rendering engines and visualization softwares out there. So in this instance, we used Dassault's 3D Experience platform as a rendering platform. And then on the right-hand side, a product from Autodesk called Bread Professional. So we can see that the materials being represented correctly in these different tools also accurate. So Pantora is the software that enables the hardware to measure, and then the Pantora software is processing that data to create these virtual materials for visualization. So basically the things that are enhanced in your workflows are things like reducing time to market. I can start to make decisions virtually without having to create a physical prototype. We can increase the ability to iterate. So we can go through a number of designs virtually before we ever have to make a physical prototype, right? So, and this improves the collaboration from design to marketing. These assets or virtual materials aren't only used in the stage of design and prototyping. These assets and digital materials could be used for marketing materials. So think web, print, whatever that may be. This also saves material and supports sustainability. we all have a sustainability goal within our organization, and this is certainly one way to do that. And it's proven to save costs. We have a number of customers who have spoken about this, including Rivian and others, where they are saving millions of dollars by working in a digital workflow versus just doing physical prototypes. So this is a use case where we looked at the interior of a vehicle, and oftentimes the difficulty comes when you're using different suppliers, different grains, different types of materials, but we need to find harmony with all those materials. But oftentimes, as we see in the image above, there isn't, perfect harmony or what the desired effect is. So by utilizing some of these tools, we can actually virtually be able to validate that these materials and the color especially, right, is going to be looking, or we're going to find harmony between those. So in this instance, we were using a spectrophotometer, so our multi-angle spectrophotometer, and then an aesthetics device to get the texture information, and so the cell info, right, the texture, grain, things like that, including gloss. So this is another way of being able to virtually validate before you ever have to bring those physical materials necessarily together in the production of the interior in this case. So why we did this partnership is we really wanted to take advantage of what Rhopoint had done with the aesthetics by creating this very, very detailed, high fidelity texture resolution for surface structure. And then taking our portfolio of spectrophotometers, we can then combine the color information from our spectros with the texture information from the aesthetics, taking what are really the powerful tools inside of each of them and bringing them together to create a final material. And I'll be doing a demo here shortly to show how that exactly works. So a basic workflow, so this will give you a quick idea, and then in the demo, you'll see it live in action. So in this case, we're measuring a sample. I have a vehicle here. This would probably be illustrated with the plastic as well. So think about that image I showed earlier, where we're measuring the plastic with our MAT12 multi-angle spectrophotometer for the color information. Then we would also measure for texture information with the aesthetics, import and process the AXF using Pantora. So that's, again, Pantora software is what we use to, process the data so that we can create these virtual materials. So we have in this slide here, you can see some textures as well as color, and then combine those to create that final AXF. And then the third step is being able to not only visualize, but actually be able to compare those data sets to maybe another version of that material from a different supplier, whatever that may be, to see where, if there is any gaps between or a large delta E between the overall color or appearance of that material. So measuring, processing, and then also having the ability to compare, analyze, and visualize those AXF files, the virtual materials. So in the quality control side of things, this is typically done. You've got a physical light booth. You're looking at the two samples side by side. Of course, this is, a proven method, but what we're trying to do is also give you the capability of, yes, I've been able to visually compare them. They look great, but I'm limited to there's still a level of subjectivity for the person that is doing the evaluation. But we also have the capability of doing this in many different lighting situations, perhaps one that's more specific to the use case for that product. We're using quality control with spectral data. So we're using spectrophotometers and different instruments to be able to do this. We're not just artistically trying to recreate it. And then we're quality controlling that as well. We're looking at the spectral data. How does it compare from one sample to the next? And really doing a more hopefully bulletproof process for doing the quality control, not only of color, but also the full appearance. So with that, I am going to hand it over to Christian Dietz to talk about the Rhopoint Aesthetix device for quality control. And let's go from there. Christian.
Thank you very much, Thomas.
Yeah.
Thanks everybody for having me today and giving me the chance to speak about our new partnership and our device, PANTORA Aesthetix. PANTORA Aesthetix is in fact the A in CNA, color and appearance quality control. And as you know, there are a multiple of devices in the market to control surface quality. You have devices to cover gloss, to measure haze, orange peel, as we call it, surface structure. You have profilometers to take the surface roughness into account and all these kind of things. So the idea was to combine all of them into a very state-of-the-art device using camera technology for characterizing the surface in a way that it becomes beneficial for quantifying appearance and also making quality control on multiple aspects of that. Please. Thomas? So the Aesthetix was developed together with the KU Leuven, the university in Belgium, as being one of the front runners for appearance measurement in gloss control. And the idea was to capture surface information in 2D with a gloss camera and also adding an observer camera under 0 degree, plus a multitude of light sources, as you can see in these images here. So we have a traditional gloss sensor under 60 degree. We have 45 LEDs circumferentially built around the 0 degree observer camera. We have a 10 degree spot and a line light. And what we do with them, I'm going to present on in a couple of minutes, please. So the idea is that you want to see, first of all, where you measure, and you want to get what you see. And this is done by having, first of all, a target or a live view, as we call it, with the observer camera. So you can really position the device on the surface where it really must be measured. We overlay target zones for whatever we want to measure with the device, and we then have full control for the user to measure certain aspects, like gloss, which would be the ellipses that you see in this image on the right side, the red ones. There is a blue rectangle, which we use for measuring sparkle, for example, and we also have the possibility to measure texture. There is more that we measure, but whatever we measure, all the images that we take have a resolution of 10 micrometer per pixel. So it gives us a very high detailed looks onto the surface. Continue, please. The way that Aesthetix is built is that not everybody needs to have full control over all aspects, which means for a lot of devices, you simply buy them as they are, and you go with a lot of features you never use. So the idea is that you simply purchase what you need it for. So we have built the Aesthetix in a modular system. We have modules we call surface brilliance for measuring gloss information and everything around it. Even have cross-cut adhesion tests where we can check durability of paint on a surface, effect finishing, measuring scratches and polishing quality, or topographic profilometric information in the texture module I'm going to talk about later. Important to note here is that every PANTORA Aesthetix is delivered with a software module, Surface Brilliance, enabling it to be used to measure all quality aspects of high glossy surfaces. Please, Thomas. So the first module to talk about is in fact this Surface Brilliance module, or we can also call it Know All About Your High Glossy Surfaces. When you're active in high glossy surfaces, you know that there are a lot of aspects that take place in perception that affect how a surface is judged in terms of quality, but you need to have multiple devices to measure them. like a gloss meter, a haze meter, an orange peel meter, and so on. And Surface Brilliant takes all of that into one account, please. Everything that we measure here in this regard in terms of gloss is compliant to ISO or ASTM standards for gloss. What we are doing here, you can see on the right side, we already said we have an observer camera that enables you to get a bird's eye view on the surface, but on the left side you also see what is actually reflected from the surface in the gloss. This is something that every gloss meter is doing. So this little rectangle that you see down there is the light spread from the light source over the surface, and the rectangle in it is what is measured. Please, Thomas. So by analyzing the whole image that we take, which is in fact 24 times 18, for example, here, this black rectangle, we take certain areas on the sensor and analyze them according to the standards. It is important to know that we take HDR images, so we take images in low, medium, and strong illumination condition, and from there on calculate what is needed. Down left you see examples of a glossy sample, which was in that case a black glass standard, showing some nice reflection, and the yellow rectangle is the area for gloss that gets integrated into a value. The ones in the middle are the haze regions, which are used for calculating haze. And we also have a new parameter developed by the KU11, which is the so-called Michelson contrast haze, which is very sensitive for slight diffusions on very smooth and glossy surfaces. Continue, please. We also have added a line light under 15 degree, and this line light is projected on the surface to calculate the parameter called waviness, or waviness describing the visual impact of what we also call orange peel. This is the effect that you have when you view a surface roughly between 1 to 1.5 meters away, and this was developed together with Audi and VW Group to capture information how a human perceives waviness on a surface, and this was embedded into the Rhopoint TAMs and now brought into this device to capture all the relevant informations. Down there you see information and aspects of ACT panels that are quite common in the market to judge waviness visually, and how a human observer would judge them. For example, down there you see a waviness of 0 where the surface is perfectly smooth compared to a very bumpy surface of ACT1. So you get a scaling value describing how wavy your surface actually looks like. Please continue. So with one shot, you get all the information you need to characterize your high glossy surface. As you can see here, we are comparing a measurement on the black glass calibration standard against the 3 ACT panels we see down there, the one ACT10 with the highest quality, ACT5 medium quality, and ACT3 on the lower end. Having a look at them, you can see that they become more and more bumpy, which is also reflected in the values you see in the table. What we have here is the 60-degree gloss value, and it also shows where we say gloss alone is not enough to judge a surface for quality, because the one with the highest quality doesn't have the highest gloss value in this case. So this is a normal effect, but you can also see that the sharpness or image sharpness that we have is dropping from the black glass to the ACT3, describing that there is a loss of detail in the reflected image on a surface. We have the indication of slightest diffusion by Michelson contrast haze that gets stronger. Log haze or normal haze values are rising, as is the waviness, which becomes quite apparent when you take a look between the first and the last image. So there are a lot of images a lot of parameters not displayed here as well. So whatever you want to have, you can choose and select for your application. Continue, please. Next on the list is what we call the texture module. Judging high glossy surfaces is one aspect, but if you're more into matte to semi-matte materials or finishes, you are interested in different aspects than haziness or waviness and these kind of things. Continue, please. For this, we have added the 450 LEDs that we fire one after the another, Thomas, to then capture the different images from all 6 illumination directions. And these illumination directions are then combined into one image, and from there on into a so-called height field, which is the gray one that you see in the middle. The gray information, or the grayscale or height field image, is used to calculate the topographic information based on the variation of brightness across the image. If you're familiar with that, this technology is also called photometric stereo, or shape from shading. Continue. Based on this information, we get a complete topographic pattern. This topographic pattern can then be used to calculate profiles from wherever we want to, coming a bit into detail in the next slides, but here we can also see that you can drag a profile across wherever you need it to not only get roughness like SA or RA, but you also can judge the appearance of the surface into different cell sizes, cell forms, and everything that we call patterns onto the surface. So it becomes a useful tool to judge whether the appearance between 2 different, e.g. leather-like structures are the same, or if it has some differences in terms of appearance. Next slide. What you can see here, for example, is that it's useful for anything, not only leather. It can be used for paper, it can be used for what we see here for powder coating. And also here you can see the differences in powder coat, and you can see how the 3D maps behave, whether there are defects on the surface. You can drag lines or profile lines through these defects, analyze your defects, how you want to see it, and get the relevant information for your tasks and workflows or your applications out of it. Here in this case, we have a similar gloss value, as you can see on the left side, but then the surfaces start to differ in terms of the roughness they have and the altitudes, which also is an indication for the haptics, not only for the visual impression. Next, please. So there is more to aesthetics and aesthetics PANTORA than meets the eye, and also on what we can discuss here in that short time frame. But just let us sum this up, that the integration into the PANTORA software, combining texture measurements with the spectral color information, is the perfect integration, and offers for customers not only to create digital twins, but also after the digital twins are created, to really judge in the aesthetic software how they compare to the references and standard in so many aspects that you might be interested in, which is not only gloss and haze, and orange peel or waviness, as we call it, surface structure, but also cross-cut and polishing and whatever may be. And with that, I guess I hand over back to Thomas, and looking forward to your presentation.
Excellent. Thank you so much, Christian. Yeah, this is really exciting. We've got a lot of capabilities with this device. And just to sort of summarize, you know, we have this integration with PANTORA to enhance the visualization side of things, add in some new quality control within inside of PANTORA. But you also have access with the same instrument to all of the Rhopoint modules that are going to go perhaps even deeper in many cases into the quality control side of things. So this device could be used not just by one group within the organization, but maybe multiple groups to take advantage of all the different modules from Rhopoint. So yeah, it's very, very exciting. And with that, I am going to do a short demo. Of course, we always love doing demos live because things never go wrong. I did create a baking show version in case something doesn't connect or doesn't work the way that I was hoping it would, but let's go for it. So when setting up, so this is the PANTORA software. And what we're doing is going to the Connect tab in here. This is where we can connect to some of our spectrophotometers and also the aesthetics device. So here you see I'm connected to 2 different devices, both the Rhopoint Aesthetix, and then we have the X-Rite multi-angle MAT12. So here's the Aesthetix device with the Pantora logo on it as well. And then I also have the MAT12 multi-angle spectrophotometer. So to jump in and do a quick demo, I'm going to choose my Aesthetix device. I've already calibrated the device. And so once that is done, I have the green light to go ahead and start doing measurements. So let's just go ahead and do this purple one again. I have given it a name. This will just be the file name as well as the material name. If I wanted to, this is the point at which I could start to add in metadata about, you know, who was the vendor, what catalog or vehicle or whatever information about the material that I want to be able to have searchable within a database, but also, you know, about who created it, who did the scan, so I can go back to that person. There are a number of things that you can add in here. It's limitless, really, what you can add as far as metadata goes. I just am telling it, where do I want that final AXF to go? So I give it a target folder, we get a path, and then after it's completed, it's going to drop into one of our material trays. So I have a few different ones down here. In this case, I want to send it to my textures one because I'm going to measure the textures with the Aesthetix device, and then we'll do the color next. So there's very little that the user has to decide here. We do give some examples, help, you know, things that can help move along, you know, or give you some information about what we're doing and help you out there. We typically want to include all of the measurement data. So by default, this is checked. And then next thing we're doing is measuring a material. So I get a live preview. If I move this around, we can see it change. So this is a live preview of, why don't I show you this lovely lavender faux leather or vinyl. So it's a two-step process. First, we need to tell the Aesthetix device to capture all of the images. So right now it's doing the capture step. And then there is a second step, which is, okay, now I need to post-process that data to do that photometric process, which Christian was just talking about, to create the texture. So if I click finish, it doesn't take very long. The whole process is very quick. I can then jump over to my editor and actually see what this looks like. So I am bringing it in here. What you're seeing is the current version. So I've got color information. I've got a normal. So this is telling us more about the texture. And then the height information is also there. Oh, this one's a little bit hard to see, but you can see some contrast in there, right? So there are two different levels of information about the texture. So what I would do here, since I've already measured this, is then edit it so that right now, if I look at the rendered version, we can see there are a number of squares here. That is from the area or region of interest that we're doing the measurement from. But we have tools that allow you to then make this a seamless material so that you don't see a number of squares. So when I bring this into my 3D software and I want to do a rendering, we don't see a bunch of squares. We're actually seeing this seamless version, which I can apply to a larger area or a larger piece of CAD geometry. Another way to see this is if I bring it into the Pantora viewer, I can actually jump in here, get a better idea of the texture, how lighting is interacting with it, the reflection, gloss, everything that I want to be able to visualize very quickly, we can do right inside of the Pantora software. So we don't have to have that 3D rendering application to be able to see the AXFs. We can do that right inside the Pantora software. So the next step is, okay, I've got this lovely leather that I'm really happy with, but it comes in a number of different colorways. Well, instead of having to measure all of the colorways and edit for making these seamless and do all that work over and over again, we've enabled the ability to then do a measurement of all of the different colorways. So it could be something that exists in the real world already, or maybe I want to experiment with leather that comes in a different color from a different manufacturer, but see what it looks like perhaps with the grain from this other supplier. So you not only can you create the digital twin of the physical, but we're allowing you to accurately take information maybe from different materials and combine them in an accurate way to do some exploration and potentially do some specification as well to the manufacturer, so that ability to communicate these ideas as well. So the way that we do this is by using, within our editor, again, we talked about creating seamless materials. We also have the ability to create variants. So I'm going to go ahead and remove this since we already ran that one. So if I have this lavender leather and I am really happy with the grain, I like the subtlety of it, I would then measure a bunch of colors with a spectrophotometer. So I did use the MAT-12 instrument and measured a bunch of colorways of the different materials. And then I just have to tell it, okay, now take that texture as my source material here. And now I want to transfer color from a measurement. Why this is different, we're not just moving an RGB slider, changing the color, because that would not be the accurate way of doing it. Obviously, the reflectivity, gloss, all of those things are going to change depending on the color that I choose or the level of gloss of that specific material. So we want to do this in a way that is accurate, and we're using the spectral color information to be able to do these variants. So this takes a little second, takes a minute to preview, but what I'm going to do is I'm just going to create a set here of different variants. So utilizing the texture of this lavender leather, but then telling it I want it in all of these other colors. And then I'm going to drop it in this folder. I already ran a version with this other tan leather, but let's do it now with this lavender leather. So, and you'll notice over here in just a second, it will update to whatever the first color is that I changed here. So you'll see this update in a minute, but while I'm doing that, there it is. I'm going to run all of my colors with the texture of the lavender leather. So I click run. It does take a second to process all of it. What we're doing is running basically a script that says, okay, now take the texture of the source material and apply the colors from the different materials. So I did this already with the tan version. So I just wanted to show we have, say, the white version of that. And here come some of the new ones. So there's the white one there. And as it's updating, we can jump to a few of the other ones. So there's the white. This one was using the tan leather, but let's take a look at what the purple leather, but with this more magenta fuchsia color looks like. So we had the purple one. So there are so many more possibilities now with what we can do utilizing information from multiple instruments. But because we're a color company and we want to do this accurately, this is a way of exploring, but also optimizing and being able to do all of these different materials in a much more efficient way. But really, it's about accuracy and exploration too. So that is the quick demo. I hope that you all enjoyed and being able to see it in real time, how user-friendly it is, how quick it is, that you're going to be able to do a lot more, a lot faster by utilizing these different instruments together with the Pantora software. So I am going to jump back over to our presentation to go to the final slide. Any questions? And thank you again for attending today. For those of you that weren't able to make it and are watching this after the fact, please let us know if you have any questions, but let's open it up to any questions live.
Thank you, Thomas and Christian. Yes, if you have any questions, please feel free to submit those now. You can do so using the questions function at the top of the toolbar. Before I turn it over to questions, I am going to pop up a polling question. If you'd like to hear from an X-Rite sales rep or a Rhopoint sales rep for any of your needs, feel free to answer that question and we can reach out to you. I will just keep that on the screen for a little bit and we will see if we have any questions. So I do see one question here. How does the PANTORA Aesthetix cope with glossy, transparent coatings on a paper substrate? Will it show the surface texture appearance of the paper or the texture of the transparent coating itself?
That is a great question. And I'm going to take the Pantora side of it. And then I think there's something of value from Christian as well on the Rhopoint modules as well. So on the Pantora side of things, it does not have the ability to separate the coating from the paper texture. We do have technology that can help with those types of materials. So really what it does is it's creating a single surface layer. So they would be combined, I guess. But it should do a great job of how that coating affects the overall appearance, right? So yeah, again, it's not going to be able to separate the two as like a matte and a glossy, or like two different height maps or normal maps for the different surfaces. It'll give you just a single value. But I think the overall appearance could be captured in a way that was very, very useful. But Christian, do you have anything to share kind of on the quality control side of it?
I think you answered most of it. The thing is that, first of all, it could, for example, if there are some double layer effects or something on the surface, you could see that in the images taken. So compared to traditional gloss meters, for example, where you would simply get a gloss value out of it and you wonder why it might be higher, then you would actually see it. Or if you measure it on something else, you could also see if there are, let's say, layer effects in there. If there's a double reflection somehow present, you would see that in the images. That's the first thing. In terms of topographics, as you already said, you would see the surface and it would take both of them together. So, but again, it would depend on the application itself. So
sure,
be happy to.
Yeah.
If there is some info, if somebody wants to try that out, we're always happy to contact and make measurements free of charge and just evaluate what we see. So if there is some interest, feel free to send us your samples and we give you a report on how they actually look like.
Yeah, I was going to say the same thing. You know, we always love challenges and trying, new things. So please send them along. There could be an opportunity too, if you're able to have a sample of the coating and a sample of the substrate and measuring them separately. We may be able to do some analysis of together versus separate.
That's true. That's true. I mean, what you can see is before and after as well. I mean, we have customers using this for coating, for example, on foils, on textured foils or something like that, where you have the before and then you see how much it builds up after measurement and how much, when, at what layer is it covered or what you actually see and so on. So there's a lot of potential, even for traditional applications, I would call them.
Absolutely. Absolutely. Good question. Thanks.
When should I use an MAT12 versus
That's a great question. So the MAT12 is also capable of doing texture in a similar way that the Aesthetics is doing it. The advantage, so, okay, maybe I should go back one step. So the MAT12 can do texture and color and glossiness and all those characteristics. The reason why we've also partnered with Rhopoint is that the Aesthetics is doing a higher resolution, as well as the MAT12 is an in-plane measurement. We're actually getting some height from the material with the Aesthetics. So it tends to be the better option for materials that have a more defined texture. So something that has very little texture, the MAT12 can do very, very well. But if we have things that are large grains or carpets or things like that, that have a larger texture height, the Aesthetics does a much better job. So it's really about the use case. But the other aspect of the Aesthetics is the camera's a bit higher resolution. The region of interest, so the size of the measurement's a little bit larger. So there are certainly, we'll have a Venn diagram list of, when to use the right device for the right job. But again, the advantage of using the MAT12 with the Aesthetics is that the MAT12 is intended for true color measurement, anything with effects, things like that. And then the Aesthetics is a great tool for surface characteristics. So with the combination of the two, you're getting like the best of two worlds. So I hope that helps to answer that.
I can also add maybe to that. So if you already have a color measurement equipment, so like you have a X-Rite benchtop, and you can simply use the Aesthetics to capture the information, or for this, as Thomas already shown, the texture information in a very high detailed state. Keep in mind that the effective resolution is in fact 9.2 micrometer per pixel, which is pretty high and 1 magnitude better than the human eye resolution. So it is a perfect add-on if you already have something at a more price-sensitive range as well. That also comes into that.
Yeah, absolutely. No, thank you. Yeah, Christian, that's a great point.
Can I use both Rhopoint Elements software and Pantora software with the same device?
Yes, you can. Yes, you can. So, yeah, Christian, why don't you take this one since you have the.
Feel free, but I can also do it. Yeah. So no, I mean, Pantora Aesthetix is the same like any other aesthetics in terms of functionality. The difference between them is that the Pantora Aesthetix is the only aesthetics device that is able to connect to Pantora Material Hub, but in terms of aspects of functionality, it's just the same as any other aesthetics on the market, which means you can use our software, our modules, our solutions for everything that comes along with it, with our solution for quality control. Yeah, so as mentioned in the beginning, if you purchase a Pantora Aesthetix, you get one license or one module for the Surface Brilliant for free on top of the device.
Awesome. Yeah. So more, just adding more and more capabilities with the additional.
Exactly.
Yeah.
Yep.
What is the size of the AXF file created in Aesthetics?
Great question. So it can range. So the straight measurement out of the here, let's just take a look really quick. So if I jump to here, just going to open this. So the combination of the texture and color will be with the combination, they're going to be, in this case, like 143 megs. That's also because I made a larger seamless version of it. If we took it raw out of the device, it's probably closer to 55 to 70 megs. But it just depends on, the size of the image. So the texture map that we looked at, the normal, the height map, the size of that map will define sort of the overall size, but out of just the raw scan before any edits are made, it's about 45 megs, somewhere in there.
All right, we're getting a lot of great questions. I will take one more question for today. If we didn't get to your question, we will do our best to follow up with you. What features might be available in the future?
Yeah, this is really good. So we started with, we're going to introduce some of the other capabilities of the aesthetics from Rhopoint in the future. We started with the texture. There was a need in the industry, in a lot of industries, to start to do more texture and topographical information and do color replacement. So that was our first integration. In the future, the next one will be high gloss surfaces, like Christian was talking about. We want to be able to quantify that as well as visualize that, because this functions also with the 60-degree camera for doing gloss as well as the other angles. We'll be able to add and enhance the overall specifically for high gloss materials. So that'll be the next one. And then because of the waviness and haze, we are looking at also being able to do things like orange peel with car paints and things like that. So those are, yeah, the future integrations that you'll see coming up hopefully in the next year or so. Anything else, Christian, that you would add?
Yeah, I mean, for us, as said, I already mentioned some of these stuff. You have to keep in mind that the aesthetics is not finished. Yeah, so you can see it as a calibrated microscopic camera system, and whatever you can do with that will be added with feature and functionalities in the future. For example, we will definitely release something for powder coating where it makes sense, or analyze powder coatings more closely, giving you some idea of that. You could even measure transmission with it, because you can also use it to measure back illuminated stuff. So you can turn off all the active lights and simply measure the information received by back illuminating some samples. So that is something that we are going for as well. Just to give you a glimpse, or to have some, whatever, name it, you got it. Yeah, so again, it's also maybe one interesting point is you as a customer can tell us what you need. So we might have some fancy ideas, but the best ideas come by combining customer input together with our expertise. So if you say, oh, I have something very specific that I cannot measure with anything, feel free. So send us your ideas, and we are happy to take a look at that and discuss with you what we can do. So
excellent point. Excellent point. Yeah, the feedback that we get is what drives what comes first and how quickly.
Exactly. Exactly.
Yeah.
As always.
As always. Right?
Exactly.
Yeah. Awesome.
Great. That was the last question we will have time to take today. So this will conclude today's webinar. Again, you will receive a follow-up email with the link to this recording so that you can watch it again or share it with your colleagues. I just want to say thank you, everyone, for joining, and have a great rest of your day.
Thank you very much. Thank you for having us, and enjoy the rest of your day. Looking forward to meeting you all. Bye.
Bye-bye.